Okay, the next example is figure 263. And whereas in the previous example we introduced the feedback command, we in the first example used unit feedback. So this example just takes it a little further, where it places a transfer function in the feedback loop. So I think it's actually the same transfer functions once again that's used. In other words, 1 over 500s squared, this will be my transfer function in the forward loop, but then the s plus 1 over s plus 2 will be in the feedback loop. And so the first part of the code is exactly the same as the previous one, but note now the difference in the feedback command. My first argument is now sys1, as opposed to the product of the two in the previous example. And my second argument is sys2, because sys2 is now in the feedback branch. The feedback branch is no longer a unit feedback, right? But it's still negative feedback in this example, and because of that, I do not have a third argument. And if I then print it to the screen, this is the result that I have. And we see that the denominator is actually the same as before, but the numerator is different. The fact that that is so comes from block diagram algebra. If I have a transfer function in the feedback loop and a second transfer function, if I've got a transfer function in the forward loop and I've got a second transfer function, whether I put that in the forward loop or in the feedback loop, the poles of the overall system will be the same because the characteristic equation of the two cases are the same. It's not the same overall transfer function, but they do have, the two cases do have the same characteristic equation. Okay, that is all on this. Any questions?